Hey guys, so here's part 2 of the 3.3 day 2 notes. Once again, we're going to be talking domain. Now this time what we're going to be doing is what happens if we were doing our operations, so function operations or compositions, and then we have a variable in the denominator. So how do we figure out the domain, okay? Now remember, what is a number that we can never divide by? 0, right? So we can never have 0 in our denominator. Well, in this case, we always have to figure out, well, what number, if we plug into x, makes the denominator 0? Because that would make our function undefined. So what we're going to do here to figure out, well, what can't we plug into x? Anytime you have the variable in the denominator, we're going to set whatever is in the denominator not equal to 0. Okay? Because this represents this number or numbers, just depending on what we get. We can't plug this into our x because it will make our denominator undefined. Okay? So we're figuring out what value makes the denominator undefined. Okay, so for our example 4, f of x, we have 3 over x. So here, we take what's in the denominator, set it not equal to 0, and solve for x. Well, here, we just know that x can't equal 0. So if we plug it into there, then we get it undefined. Now, don't forget, we have to write domain in interval notation. Okay? So how would we write this if basically the only number that we couldn't have in our domain is 0? Well, we can have all negative numbers, right? So to represent that, all negatives, we go from negative infinity. Now 0 can't be included, but everything before or after it can. So because it can't be included, we use parentheses to represent that. Now, that represents the negative numbers, or numbers that are smaller than 0. Now, let's talk about what are numbers that are bigger than 0. We have to include that. Now, once again, we use parentheses around the 0 because that can't be included in our domain. But to represent all the positive or all numbers bigger than 0, we go to positive infinity. Okay, let's try example 5. So we're going to do the same thing. We're going to set what is in the denominator not equal to 0. Because this is representing, hey, what number can't we plug in? So to solve, I subtract both sides with negative 4, or yes, I subtract both sides by 4, and then I get x equals can't equal negative 4. Because if we plug negative 4 back into our denominator, negative 4 plus 4 gives us 0, and makes that function undefined. So that means any number smaller than negative 4 works. So we go from negative infinity to negative 4. And remember, since negative 4 is not included, we use parentheses. Now we need to represent all the numbers larger than negative 4. So we go from negative 4 with parentheses, since it's not included, to positive. Okay? And one thing is, don't forget that remember we used this when we did like absolute value inequalities and quadratic inequalities. Okay, now what I would like you to do is go hit pause the video and try example 6. Find the domain. Okay, let's see what you got here. So we're going to set our denominator not equal to 0. So it's going to be that equal and then a slash, that means not equal. Now we solve, so I get 2x not equal to negative 7. And then I get x equals, because I divide both sides by 2, x doesn't equal negative 7 halves. So the only number that doesn't work in our domain is negative 7 halves. So to write this in interval notation, remember we think of all numbers smaller than negative 7 halves, that'll be negative infinity. And we go up to negative 7 halves, but don't include it. And then all numbers to represent that are larger than negative 7 halves, we go from negative 7 halves to positive infinity. Okay, make sure you watch part 3. That's where I'm going to kind of talk about when we do our operations of functions and compositions and how to find those domains.